In today's video, I am going to explain the properties of lattices, and this topic is for mathematical foundation for computer science. So here, according to the properties of lattices, so we have to take a finite set L here, and less than or equal to be the relation on this set, and L less than or equal to be a lattice. And I am taking two operations here. So this one is join and this one is meet, and I am going to operate this on this set. So first one is an idempotent law. So according to the idempotent law, so let L less than or equal to be the lattice, and I have taken only a single value, that is A belongs to this set L less than or equal to, and operations here are join and meet. A join A is again A, and A meet A is also A. So I have to prove that. And next one is commutative law. So in this set I have taken two elements, that is A as well as B, and these are the operations. So according to these operations, we have A join B is equal to B join A, and A meet B is again equal to B meet A. And next, coming to the associative law, see here, A join B join C is equal to, this time A join B join C. And the next one, coming to the meet, A meet B meet C is equal to A meet B meet C. And next one, absorption law. According to the absorption law, A join A meet B is equal to A, as well as A meet A join B is also equal to A. So these are the major, most important properties of lattices. And now I am going to show the proof of these. First property is nothing but the idempotent law. So according to the idempotent law, let L less than or equal to be a lattice and A belongs to L. So this is a finite cell set, and I have taken a single element here in this, from this set, and then we have to prove that. So after then we have to show, and before then it was given in the statement. So now we have to show that A join A is equal to A and A meet A is equal to A. So here, coming to the A join A join A is nothing but the least upper bound of the set A comma A. What is the least upper bound here? See, let me explain you one thing here. So if you take any set, see for example 5 or 10. So if you have taken, so 11, 12, 13, 14, everything will be the upper bound of this set, and this 4, 3, 2, everything will be the lower bound of this set. Out of all these lower bounds, so what is the greatest lower bound is nothing but the infimum, and out of all these upper bounds, least one, so least upper bound is nothing but supremum. So this is the supremum value, this is the infimum value. So this is also a lower bound, this is also an upper bound. See here, what is the relation? So out of all the upper bounds, the least upper bound is the supremum, and out of all the lower bounds, the greatest one is the infimum. So that is the difference between supremum and infimum. See here, A join A can be written as the least upper bound. See, out of all these upper bounds, the least is nothing but the supremum value of A comma A. So the least upper bound of A is again A. So as it's a single element set, so supremum will be the same thing and the infimum also will be the same thing. Therefore A join A is equal to A. And coming to this A meet A, so here it is the least greatest lower bound. See here, for this set 2, 3, 4, everything are the lower bounds here. So out of all these lower bounds, the greatest lower bound is nothing but the infimum value. As it is a singleton set, the greatest and the least value is the same thing. Therefore the greatest lower bound of the set A comma is again equal to A. Therefore A meet A is equal to A. So got it? The next one is the commutative property. See here, according to the commutative property, the statement states that let L less than or equal to be a lattice and A comma B belongs to the set L. So I have taken two elements in this set. So now I have to show that A join B is equal to B join A, and A meet B is equal to B meet A here. See here, L less than or equal to be a lattice. So first, so this is then. So before then it is given, and after then we have to show. So A and B belongs to the set SL. Now we have to prove that A join B is equal to B join A. So it's very clear. What is A join B? Least upper bound, which is nothing but supremum of the set A comma B for this set. So this value is the supremum. So the set elements can be interchanged. So least upper bound of B comma A. I have interchanged these. So this can be written as B join A. So I have taken A join B and I got B join A. Therefore A join B is equal to B join A. And coming to meet, A meet B is equal to B meet A. So what is A meet B? So it is nothing but the greatest lower bound of the set A comma B. So we can interchange these elements and I have written greatest lower bound of B comma A. So which is nothing but B meet A. Therefore A meet B is equal to B meet A. And the next one here is associative law. Coming to the associative law, L less than or equal to, L is a finite set, less than or equal to B, be a relation on this set, and L less than or equal to be a lattice. And I have taken from this finite set 3 elements A comma B comma C. And now, and let me explain you, this is join and this one is nothing but meet. So coming to the join, A join B join C is equal to A join B join C. Here A meet B meet C is equal to A meet B meet C. So let me tell you what is given here. Let L less than or equal to be a lattice. See here, clear? And from this finite set I have taken A comma B comma C belongs to the set L. Now to prove that, so what is it I have to prove that? A join B join C is equal to A join B join C. And let me tell you, so I have taken this one as X and this one as Y. So let us suppose that let A join B join C is equal to X, and next A join B join C is equal to Y. Now to prove that, so what is it I have to prove that? X is equal to Y. So I have to prove that X is equal to Y. For showing X is equal to Y, so I need to show X less than or equal to Y for one time and X greater than or equal to Y for one time. So if I have shown these two, I can easily conclude that X is equal to Y. And now what is given here? So it is given that X is equal to A or A join B join C. And what does it means? X is equal to, this is nothing but, so according to A join B join C, so this is nothing but the least upper bound of the set. What is the set? A comma, this is B join C. B join C. So what is the least upper bound? So I have shown you, out of all these upper bound, the least value is nothing but the supremum. Therefore, this value, X value, acts as a supremum for this set. So if this is supremum, so for each and every element, X will be the supremum value. So A less than or equal to X, and for B join C also, X is the supremum value. See here, A less than or equal to X, and see here for B join C also less than. So this is the point which you have to keep in mind. So B join C is less than or equal to X. And coming to B join C, so this is nothing but the least upper bound of the set. Which elements are there? B comma C. What is the least upper bound? So least upper bound is nothing but the supremum. So this value acts as a supremum value for the set B comma C. So this is nothing but the supremum value for B comma C. So for B, which is greater, supremum value is greater. B join C. And again for C also, this one is greater. So B join C. So according to 1, so according to the equation 1, so we can from 1, see here from 1 we can join this one. B less than or equal to B join C less than or equal to, and extend this one X. And here C less than or equal to B join C less than or equal to, here it is X. See here, let me show you one fine thing here. So what is here? X is less than, A is less than or equal to X here, and B is less than or equal to X, and C is less than or equal to X. The same thing I am writing here, that is A less than or equal to X and B less than or equal to X, and again we got C less than or equal to X. And I need to show, see here I have taken X and I have to show this relation or towards Y. So what is there here? A join B is there. So I am clubbing these two. See here I am writing A less than or equal to X and B. So this B less than or equal to X, and I am leaving this outside, C less than or equal to X. So this can be written as, this is A join B less than or equal to X and C less than or equal to X. And see here, and I can even join this one, that is A join B join C. So here join C less than or equal to X. So A join B join C is nothing but Y here. So I am writing Y less than or equal to X. So we have got that Y less than or equal to X. From this I am taking this equation as 1, and now I have to start with Y. See here, for one time I have taken the X value and I have started. See here, this value X I have taken and I concluded that Y is less than or equal to X. Now I am taking Y value. See here, so what is our Y value this time? Y is equal to A join B join C. So similar here, Y is nothing but the least upper bound of the set A join B comma C. What is the least upper bound? Least upper bound is nothing but the supremum. So Y is the supremum for this set. So the relation here is, for this element Y value is the supremum value. For C, Y value is the supremum value. And see here, note this relation. So after noting this relation, see what happens. Now coming to this A join B. So A join B is nothing but the least upper bound of the set. What are the elements here? A comma B. So least upper bound is nothing but the supremum. So this is the supremum value for this set. So the relation will be, supremum will be, what is this? The least upper bound, that is A less than or equal to, so this value will be, the supremum value here is, so the supremum value will be this side, A join B. And the next one for B also, the relation will be, the supremum value will be, see here, A join B. And see, if you observe, I have a connection here. So for A join B less than or equal to Y, from, so if you consider this as some relation, so one I have taken. So this value, take it, make it 2. So if this is 2, from 2, I can extend this one. I can extend this one. That is A less than or equal to, this is A join B, and here I can extend as Y, and B less than or equal to A join B less than or equal to Y. And if you see a property here, A is less than or equal to Y, B is less than or equal to Y, and here C is less than or equal to Y. So here, if I take all these elements or relations here, so here according to this one, that is A less than or equal to Y, and here it is B less than or equal to Y, and again C less than or equal to Y, C less than or equal to Y. So I need to relate with X here. So what is X here? So it is A join B join C. Now I have to club these two. So this value is A less than or equal to Y, and I am clubbing this two, that is B less than or equal to Y and C less than or equal to Y. So this is A less than or equal to Y, and if I club these, so this will be B join C less than or equal to Y. If I club these two, A join B join C less than or equal to Y. So this value is nothing but, let me show you, A join B join C value is nothing but x now. So this is x less than or equal to y. And let me show you, this is x less than or equal to y. And here I have shown you y less than or equal to x is, see here, name it as A. And now this one is x less than or equal to y, name it as B. From, see here, A as well as B. So what is A here? So A is nothing but the relation y less than or equal to x. So this is y less than or equal to x and x less than or equal to y. Therefore x is equal to y. So what is our x value? So x is nothing but, and let me show you what is our x here. So x is nothing but A join B join C. Therefore A join B join C is equal to, what is our y here? Y is nothing but A join B join C. A join B join C. And this is our associative property. See here, it's very simple if you follow this one. So if you don't understand, please go through this video for one more time. Definitely you can understand. And there is one more property, and that is also very important. That is absorption property or law. So L less than or equal to be a lattice, and I have taken again 3 elements A, B, C from this, and now I'll cut short this one. And see here, what is taken here? L less than or equal to be a lattice. So from this finite set, I have taken 3 elements. Let A, B, C belongs to the set L. Now to prove that, so which one we have to prove? A join A meet B is equal to A. And see here, what is A meet B? So A meet B is nothing but the greatest lower bound of the set A, B. See here, this is A, B. So if it is the greatest lower bound is nothing but the infimum value here. So this value is nothing but the infimum for the set A, B. If this is the infimum value, see the relation between these two. Infimum value will be the least value for the set A, and A meet B less than or equal to B. And see here, so there are two relations here. So if this is infimum value for the set A, B, so this will be the least value, less than value for these two elements. And see here, also we have according to the idempotent law, A less than or equal to A. So if I club these two, A less than or equal to A and A meet B less than or equal to A. See here, if I club these two, and if I join, so A join A meet B, so this is less than or equal to A. This is condition number 1. And next, see here, this is condition number 1, and now I have to show the same inequality in opposite sign. So also by definition, see here, according to the definition, A join A meet B is equal to, for join, see here, it is the least upper bound of the set. So this is first element A, and this is A meet B, the second element. See here, what is least upper bound? So least upper bound is nothing but the supremum value. So supremum, so this value is nothing but the supremum here for the set A, A meet B. So how we have to relate these two? So for each and every element, this value is the supremum value, that is A join A meet B. And this is our second relation. See here, if you find these two relations 1 and 2, from 1 and 2 we can conclude that, from 1 and 2 we can conclude that, see here, A join A meet B is equal to A. So from 1 and 2 we can conclude that A join B meet A meet B is equal to A. Next, by principle of duality, see here, by the principle of duality, so we can interchange join to meet and meet to join, that is A meet. A join B is equal to A. So this is how we have to prove all the 4 properties here, and if you go through this video for one more time, definitely you can understand. So please watch my videos and definitely it will be very helpful, and this is the easiest topic if you follow these videos. Thank you so much for watching, and please follow these videos, and these are the most important properties. And if you really like, please practice, share it with your friends and subscribe to this channel.